Welcome to the deep dive. You know, um, you asked us to look into friction, but without getting bogged down in all the textbook stuff.
Yeah.
We heard, so we got a few different things together. One of them has this really incredible name. It's the Static and Kinetic Frictional Model for Primary School Science Inquiry, VVT, JavaScript, HTML5 Applet Simulation Model.
Oh,
Yeah. And it's like it sounds kind of crazy, but even looking at something that's for primary school, we can kind of get some insights into this topic.
yeah, definitely. I think, friction is something that we experience every day, but don't always think about.
Right.
It's actually a very fundamental force that shapes our world.
Mm-hmm.
And so let's start with the basics. What are static and kinetic friction?
Lay it on me.
All right, so imagine you're trying to push a heavy box across the floor.
Uh-huh.
When you first start to push the box, it's almost like it's glued to the spot. It doesn't want to move. And that's because of static friction.
Oh, okay.
So static friction is the force that prevents an object from moving when it's at rest. But if you keep pushing, eventually you'll overcome that initial resistance.
Yeah.
And the box will start to move.
Right.
And now you're dealing with kinetic friction.
Oh, okay.
So kinetic friction is the force that opposes the motion of an object that is already in motion.
So it's like these two phases, almost like first holding it in place, and then as soon as it starts moving, it's a different type of friction.
Exactly.
Yeah.
Yeah, and this simulation model that we're talking about,
Yeah.
it does a really great job of taking these kind of abstract ideas and making them visual.
Okay.
And it uses images of everyday materials like iron, rubber, glass, wood.
Oh.
So you can actually see how these different surfaces interact with friction.
I can almost picture it now, like dragging a block of wood across like a piece of glass versus a piece of rubber.
Exactly.
It would take a lot more effort to get it across that rubber.
Right.
So is it always true that heavier objects are going to have more friction?
That's a great question, and it's a common misconception.
Okay.
While weight can play a role, it's not the only factor determining friction. So it's more about the force that's pressing the two surfaces together.
Okay.
And we call this the normal force.
Gotcha.
And this normal force is influenced by both the object's weight and also the angle of the surface it's on.
So it's more complicated than just like how heavy something is.
Right.
So besides changing the surface materials, is there anything else we can do in this visual model?
Yeah, so you can actually adjust the velocity or the speed of the object.
Oh,
And that also impacts the friction.
okay.
And so you can play around with those different factors and see how that affects the overall resistance.
So is that kind of why it's harder to brake when you're driving on a wet road?
Yeah, that's a great example.
Because the water is changing the friction
Exactly. The water gets between the tire and the road surface, and it reduces that friction.
and reduces the grip.
Exactly.
Oh, wow. This is so cool. This primary school model, it's like blowing my mind.
Yeah, it's great.
There's so much more to friction than I realized.
Yeah. Yeah, there's a lot more to unpack here, and this really just kind of lays a foundation for all of that.
Yeah. This is awesome. I'm already looking at everything around me differently now.
That's great.
All right, so I think we should probably stop here, and we'll pick this up in part 2.
Okay.
We'll delve a little deeper and, give some more examples of this in the real world and how it impacts us.
Sounds good. Welcome back. Are you ready to jump back into friction?
Oh, yeah. I'm excited to hear about those deeper layers you mentioned before.
Well, we talked about static and kinetic friction,
Right.
but there's another important concept, coefficient of friction.
Okay, that sounds complicated.
Well, it's not too bad, basically. Think of it as a way to measure how much friction there is
Okay.
between two surfaces.
Gotcha.
And it's a number that basically represents the relationship between that force pressing down the normal force
Right.
and the frictional force.
Okay.
So it tells us how sticky or slippery two surfaces are.
So a higher number is more friction.
Exactly.
Lower number is less.
Yeah. And you can think about it like this. Imagine a block of wood sitting on a table.
Okay.
The coefficient of friction between the wood and the table is going to determine how much force you need to use to start the block moving.
Right.
Now, if you imagine taking that block of wood and replacing it with a piece of ice,
Okay.
the coefficient of friction between the ice and the table is going to be much lower.
So it'd be easier to push the ice.
Exactly. It would take much less force to get that ice moving.
So I'm guessing designers and engineers really have to understand this stuff.
Yeah, absolutely. It's crucial in a lot of different applications.
Yeah.
Like if you think about a car tire,
Mm-hmm.
you want the tire to have a high coefficient of friction.
Right. You need the grip.
Exactly. It needs to grip the road for braking and cornering and everything.
Right.
But then you think about something like a ball bearing.
Okay.
You want that to have a really low coefficient of friction.
So it spins freely.
Exactly. You want it to rotate smoothly and easily.
Wow, so we use this friction in all these different ways. It's amazing.
Yeah, it's everywhere. Friction is essential for so many things.
Right, like just picking things up.
Yeah, holding things, walking, driving.
We've been saying how important friction is, but are there ever times we actually want less friction?
Yeah, absolutely.
Or is?
Think about engines and machines.
Yeah.
Friction creates heat
Oh, right.
and wastes energy.
Okay.
So we want to reduce that.
And that's why we use oil and stuff?
Exactly.
Yeah.
Lubricants like oil or grease
Yeah.
reduce the friction between moving parts.
Oh, so that's how it all works.
Yeah, and that allows those machines to run much more smoothly and efficiently.
So it's not always a bad thing.
Right? Friction can be a nuisance that we want to get rid of,
Right.
but it can also be really beneficial, and we use it to our advantage.
So it's really all about how we work with it.
Exactly.
Yeah.
Yeah. And another way we can reduce friction is by changing the shape of an object.
Oh, okay.
So if you think about like an airplane or a race car,
Mm-hmm.
they're designed with those smooth, streamlined shapes.
Mm-hmm. Right, to reduce drag.
Yeah, exactly. And that helps to reduce the friction with the air or water.
So it's like this big puzzle figuring out how to manage friction.
Exactly. And sometimes we want to get rid of it, and sometimes we want to enhance it.
Wow, this is blowing my mind. I'm really starting to see friction everywhere now.
That's great.
We've talked about friction between solid things, but what about in like water or air?
Yeah, that's a great point. That's a whole other area called fluid friction.
Oh, so there's even more types of friction.
Yeah,
I guess that's for another deep dive.
definitely. Yeah.
Well, I think this has been a great overview of friction so far.
Yeah.
Why don't we recap the important points before we move on? We're back and ready for more friction fun.
It's been a really interesting journey so far, right?
Yeah, it's crazy how something that's so everyday can be so complicated and cool.
Definitely. Just shows how much we take for granted. I mean, we've gone from basic definitions to, how this stuff shapes everything around us.
Yeah, and it all started with those two main types of friction, static and kinetic friction.
Yeah.
It's amazing how just pushing a box across the floor can explain so much about those ideas.
It really does show how, these simple things can reveal these really important principles.
Yeah, and then we went on to that crazy named simulation model.
Right, from Singapore?
Yeah, exactly. That's meant for primary school.
Yeah.
And even that had some really cool stuff in it for us.
Yeah, definitely. I mean, it really helped to visualize the idea of friction.
Yeah, I loved how you could see the difference between like glass and rubber and how hard it was to move something across those surfaces.
Yeah, and that really highlighted, that coefficient of friction that we talked about.
Right, that number that tells us how sticky or slippery something is.
Exactly.
It's amazing to think that engineers used that stuff to design things like tires.
Yeah, or ball bearings.
Right, so they can get just the right amount of grip or slipperiness.
It's really fascinating how it all works together.
Yeah, and we even saw how sometimes you actually want to reduce friction.
Right, like with lubricants.
Yeah, that was a cool realization that friction isn't always a bad thing.
Yeah, sometimes it's the enemy and sometimes it's our friend.
It's crazy how much I've learned about something I never really gave much thought to before.
It really changes how you see the world, doesn't it?
Yeah, totally. I'm already looking at things differently, noticing all the ways friction is at work.
That's what we hope for with these deep dives, to really spark that curiosity.
And, we talked a lot about friction as a force that kind of gets in the way.
Yeah, something that slows things down.
Right, but it's also the thing that lets us move in the first place.
Think about trying to walk on a surface with zero friction.
You'd just be flailing around.
Yeah, you wouldn't get anywhere.
That's a really cool point, that it's both a challenge and something we need.
It's all about finding the right balance.
Well, this has been an awesome deep dive. I feel like I have a whole new appreciation for friction.
Me too. It's definitely a force to be reckoned with.
Absolutely. And to everyone listening out there, thanks for joining us on this exploration of friction. Keep that curiosity going, and we'll see you on the next deep dive.